Assalamualaikum warahmatullahi wabarakatuh.
I'm Kaysa Fardatus Rizqie.
I'm Rizqie.
We are the Kategori Pioneers
From State Islamic Senior High School to KUDUS. Treatment for syphilis reported by the CDC from Indonesian Health Ministry is intramuscular injection of benzathine penicillin G applied to patients with primary, secondary, and early latent syphilis. Treatment using penicillin will cause a serious hospital reaction which causes headaches, fever, muscle pain, and chills.
Research conducted by Jumadin et al. 20 and 23 showed that star fruit positively contains secondary metabolic compounds in the form of flavonoid, alkaloid, phenol, and saponin, which can be used as antibacterials. The use of compounds for antibacterial from natural ingredients will be more environmentally friendly, safe, and easy to obtain.
One of the research methods used in this research is in silico, which is an approach that focuses on the use of software or computers in testing a compound. This method is used to analyze a chemical compound and the resulting interactions. In silico can provide predictions of the activity and properties of candidate drug molecules before further testing is carried out in the laboratory.
Based on the therapeutic techniques that have been applied, syphilis sufferers experience a serious hexamer reaction after treatment, which result in several very painful effects. The study used microneedle patch as an antibacterial product. Patch characteristic tests were also carried out further in the laboratory. Microneedles have advantages such as minimal pain, faster onset of action, higher permeability, and more effective.
Based on the background, we decided to do further research entitled SYMPHOMY, Syphilis Microneedle Patch of Aphora bilimbi, antibacterial study of microneedle starfruit leaf extract against Treponema pallidum bacteria in silico.
The formulation of the problem in this research are: first, what is the phytochemical content of starfruit extract? The second, how effective is starfruit extract inhibiting Treponema pallidum bacteria in silico? And the last, what are the characteristics of microneedles product from starfruit extract?
The objectives of the research are: first, knowing the phytochemical content of starfruit extract; second, to determine the effectiveness of starfruit extract in inhibiting Treponema pallidum bacteria in silico; and the last, knowing the characteristic of microneedles.
The crushed and dried leaves are mixed with ethanol in a ratio of 10:1. After mixing with ethanol, the mixture is filtered using filter paper. The filter results are placed in a water bath at a temperature of 70 until 80 Celsius degree for 2 hours. A thick extract will be obtained after 2 hours. Before the extract is used for making microneedle patches, the extract is subjected to phytochemical tests.
Formulas are mixed in a beaker. The mixture is heated on an electric stove, then 5 ml of water is added. The mixture is stirred until thick. The resulting polymer is poured and stored. The polymer is smeared to the microneedle mold. The holes in the mold are ensured to be filled with polymer. Then the mold is placed in the oven at 80 Celsius degree for 2 hours. The resulting dry polymer is removed from the mold.
The patches made are subjected to characteristic tests. Silico testing is divided into pharmacokinetic prediction carried out in Swiss ADME and toxicity prediction carried out in Protox. First stage in the molecular docking stage.
The results show the RMSD value is 0.496. This shows that the validation ligand is the best docking pose. The docking process carried out is valid, and the receptor can be further used in the molecular docking process using the test compound ligand. Compounds that fulfill Lipinski's rule of 5 will be used for toxicity prediction for molecular docking with the target receptor. Based on the pharmacokinetic predictions, there are several compounds that do not meet Lipinski's rules. Therefore, these compounds cannot be used for further molecular docking stage. Test compounds that meet Lipinski's rules are predicted for toxicity. Based on toxicity predictions, 3 compounds were found that had low LD50 values. Therefore, these compounds cannot be used further in the molecular docking stage. The expected result of the test compound ligand is that it has a lower affinity value than the native ligand. The results of molecular docking showed that none of the ligands in the test compounds had a lower affinity value than the native ligand. The lowest affinity is -7.3, which is close to the ADN affinity value of -8.0. This proves that the compounds in starfruit are predicted to be close to effective in inhibiting the Treponema pallidum bacteria. The compound that has the closest affinity value to the native ligand has conventional hydrogen bonds, which are similar to conventional hydrogen bonds in ADN. Similarities in other bonds in this compound with the native ligand were also found. This shows that the intermolecular interactions in the starfruit compound have stability and have the potential to bind with Treponema pallidum.
The result of observing the flexibility of the patch is in all formulas were good flexibility. The test results show that the folding strength of the 5 hydrogels in the formulation is good. In the color test, the color becomes more intense as the amount of extract is used. Based on the result of this test, all patch preparation passed the pH test, with the same result from Formula 1 to 4 with pH of 4, while Formula 5 received of pH of 5, which is thought to be because it has more extract. The result obtained turned out to be more than the standard deviation, namely less than equals 0.005. So, all patch preparation did not pass the weight test. All ingredients meet the requirement, namely a shrinkage percentage below 9.29%, except for Formula 5. Formula 1 with 0% extract has a moisture absorption capacity of 30%. It can be concluded that adding extract to making patch can improve moisture absorption for the better. From microscopic observation with 100-time magnification, what was obtained was that there were needles or nanoemulsion in patch of Formula 1 to 4, whereas when observing Formula 5, the needles or nanoemulsion were visible faintly or not at all.
The active starfruit compound, most capable of inhibiting Treponema pallidum bacteria, has affinity value of -7.3, which is close to the native ADN ligand of -8.0. The phytochemical content of starfruit extract is positive, containing flavonoids, alkaloids, saponins, and tannins. And the last, the base formula produced from the microneedle prepared patch is F2 formula.
And the suggestion is it necessary to carry out direct in vitro and in vivo tests to test the effectiveness of starfruit compounds and research materials.